So thank you everyone for your interest in the exciting topic of code change. It actually is a very interesting topic. It all depends on how much you interact or intersect with it in your particular world. So we'll give you an update on a list of topics, and one is code harmonization across Canada. We'll look at glass and glazing changes, child fall protection changes, fenestration energy performance, combustible window frames. I'll touch on encapsulated mass timber construction briefly, and its relationship to combustible window frames, and possibly accessibility changes, although if that's not something of great...
Hey, Al, the online participants are not seeing the presentation.
Okay, so our IT person will take care of that. There we go. So yes, these are the topics that I just enumerated that are on the slide you have here. And could you please tap the presentation so that so my clicker will work on it. There we go. Code harmonization across Canada. So when Canada signed a free trade agreement with the US, they made code harmonization a national priority. There is a construction codes reconciliation agreement between the federal government and provinces and territories that obliges all parties to reduce the number of technical differences in the codes, to release new and increasingly harmonized versions within 24 months of the national code, to transform the code development process to be agile code development. It'll be interesting to see if we can do that. Right now, the code development process is very conservative. You don't change anything unless you have a really good reason, and then you have to make sure all the people in the country agree with you. And there are all kinds of stakeholder groups that have vested interests in certain things. And so it's a system that is inherently resistant to change. And trying to make, in the software world, you have something called agile code development, where instead of building the whole thing from a blueprint, you just build little bits and pieces of it and they start working, and then you start selling a half-baked product, you keep adding on to it, and you're sort of always building bits and pieces of it at the same time, co-developing. The code process can be, we'll see if they can make it agile, because we certainly need to if we're going to tackle climate change. And they estimated a huge economic benefit of up to $1 billion by 2028 if we succeed in that. In the current code cycle, I think we're expecting significant harmonization of the provinces with the 2020 code, and I think in the next code cycle they're expecting it to be complete on all major matters. On energy performance, all provinces are expected to adopt the tiered approach, except Ontario and BC, which will deviate a little bit from it. And I don't know about Quebec, and I don't know if Robert is watching us today, but if he has any information about Quebec, we'd like to learn more about that. Glass and glazing changes. So there are a few, just a couple of new standards in the code. Well, actually one that affects our industry. The latest version of the safety glazing standard is now in the code. And there's an old standard that had been taken out that was put back in. The 1991 spandrel glass standard was put back in because even though it's outdated, it's better than nothing, and there's no comparable standard to it, not even in the US, that covers that apparently. So that is why it's in the code. So we have these two standards, changes in the table of reference documents in the National Building Code. So safety glazing changes occur in a number of places here in the code, and we'll look at them quickly. The new safety glass standard now covers many varieties of safety glass. So applied films and organic coatings can now be used to make safety glass, in addition to just tempered and laminated glass. And one thing, of course, that we know is that annealed wired glass doesn't satisfy the safety glass testing criteria that we have. And so wired glass is not considered a safety glass at all in this standard. But unfortunately, the old wired glass standard is still in the code, and it was called wired safety glass. Because back in, when was it, 1990? I guess they still thought safety glass was the wired glass was a safety glass, or should be considered that way. And some people feel that's a problem because you can have significant cutting injuries if you encounter a piece of safety glass, of wired glass violently, and unfortunately, it is still considered a safety glass in the code. Hopefully, they'll deal with that in the next edition. So here in transparent doors and panels, a glass door shall be constructed of laminated or tempered safety glazing conforming to the new standard, or wired glass conforming to the old wired glass standard. And that's pretty much typical in the code. Wherever you have doors and side lights and areas where you would think there should be safety glass, the wired glass standard is co-referenced with it. In part 3, in part 9, identical language. Even glass in guards is still allowed to be wired safety glass. So now, the code did pay attention to this in bath and shower areas. And so the old code said that glass other than safety glass shall not be used for a shower or bathtub, but wired glass is in a standard called safety glass, and the code allows it to be used everywhere else you use safety glass. So technically, wired glass theoretically could have been used in baths and showers. So they did make a point of getting rid of that and going farther and just saying that the glass in tubs and showers shall conform to Class A of CGSB 12117. So that's the highest class of impact test in the safety glass test. So that's the kind of glass that goes into bath and tub and shower enclosures. There is one place in the new code in a new subsection in part 3 called assembly occupancy, where there's a whole set of new requirements. This assembly occupancy has been inserted as a new subsection in part 3. And this is an occupancy or use of a building or part of a building by a gathering of persons for civic, political, travel, religious, social, educational, recreational, or like purposes, or for the consumption of food and drink. So basically, wherever people gather, presumably in restaurants as well, you would be having an assembly occupancy, and the code now is requiring these occupancies to have safety glass in them. No, and this is what's interesting. In this new occupancy, the proposed change proposed that only safety glazing conforming to the new standard could be used where there is greater risk of human contact with the glass. So, and it's an interesting PCF or proposed change form to read because they explain the rationale for why they decided to do what they did. And that's helpful to know. So I've created a diagram to show how that works because it's a different set of requirements than you might think. So the bottom edge of the whenever the bottom edge of the glass, the exposed edge of the glass is above 1,525 millimeters from the walking surface, you don't need safety glass. So that's what the dotted line there is. So I've drawn a 6-foot man to scale with some doors and windows, and anything above 1525 doesn't need to be safety glass, but anything at 1525 or below does need to be safety glass. And it's interesting, they chose that number because they looked at some studies and it seems to be the average person's eye level. And they figure that, if you're falling, you'll protect your face with your hand or something. But in other words, you won't need safety glass above that point. The other condition is the glazed opening the door is not wider than 75 millimeters. And The third condition is the horizontal distance from a walking surface to the glazing on either side is 915 or greater. So if you can't get closer than 915 to the glass, you don't need it to be safety glass. So that's an interesting set of new requirements that, if they include restaurants, might include changes to glass in new restaurants. So do these requirements make sense, especially the one where wired glass can be used doors and door side lights? You know, if industry participants are consider that, you know, should we propose to remove wired glass from those areas of the code except where it's required for fire safety? That's something that could be considered, and I think a really good case could be made for that. You guys have any thoughts on the matter? I don't know. I know that, pardon? You mean wired glass? Well, it's, you know, they need it in areas where you want the glass to remain together in a fire, so that safety, the wired glass will break and crack, but it won't fall out of the opening. And that's really the only reason it's probably still in the code, is that there are so many areas where we need it for that kind of a reason. Yes. Oh, the world needs to hear what you're saying. This is good stuff. Could you start over?
Sure. So basically what I was saying is that there's so many options nowadays, and the more it goes, the more these options are actually marketable. It makes sense. They're commercialized all over the place, and it doesn't make sense to keep wire glass in the code especially as a safety glass. I mean, the main reason why it was kept was for fire rating, but there's really no reason why we should tolerate that anymore. That's my take on it.
I think that makes a lot of sense. And I suspect it might be that they left it in this code cycle just because it was so much work to go through all the places safety glass is specified and figure out, you know, can we do without it there, right? Some people might argue that, yes, there are options, but they are not cost effective. They're very expensive. I don't know if that's the case. Not so true anymore? Okay, yeah. So anyway, it's something, you know, anyone can propose a code change. You don't have to be rich or famous. But if you have a good point to make, you can certainly propose a code change. And I think this one would be very simple to write. You don't even need a consultant or specialist to help you write it. It's just that there's you know, a lot of evidence to show how dangerous wired glass is. And we now have many options to wired glass in combustible, you know, to deal with fire. And we also have a safety glass standard that it doesn't conform to. So it's really high time to address that.
So if I can jump in, I just sent a chat message. Can we get on the same page? Can you explain, or can you summarize for us, what is the definition of safety glass in Canada per codes?
It is, well, I don't know if it's defined in the code, but there's only one standard recognized to qualify safety glass. And it is harmonized with the American standards for qualifying safety glass. And the safety glass testing requirements are very similar in Europe as well. So if
you just hit the nail, because you and I had this discussion before.
We did.
Why can we not? I mean, there is no equivalency.
Well, no, here's the problem, Emmanuel, is because they do not label the safety glass in Europe. And you can't, and if you try to find out from a supplier whether the glass was tested to the European standard and which specific rating it got, it's very hard to get that paper. So if it came with a label that showed its rating, and then you could compare it to the North American rating, I think you would have no problem. But because the test methods are very similar, They test the same size specimen. They test it with the same impact load. They allow use of a rubber tire impactor instead of a shot bag of lead, but essentially they're designed to do the same thing. So, so that's the problem, Emmanuel. It's not so much the differences of the standards as we expect it to be labeled here, and the glass company that makes it labels it, and in Europe they don't do that.
Okay, I understand. But my problem was, when we talked, that the Canadian standards would not even mention laminated glass.
No, that's not true. The standard explicitly deals with laminated and tempered glass. The old one did, and the new one does as well. So yes, they do address laminated glass.
Okay, so the whole thing is, are we producing laminated glass in North America? We can source it here, or do we have to go to Europe and then we don't get all those labels and classifications?
Well, if you want it to be code compliant, it needs to be sourced here or labeled properly somewhere else.
But because of the lack of instructions and definitions in whatever we have going as standards in North America, the glass manufacturers have no interest in adding this process, which we know is far better.
There's no lack of documentation. It's just not an industry. They do certification differently in Europe, and they trust the glass suppliers and the window manufacturers to have quality procedures in place to comply with their standards, and they don't.
That's the problem. This is where everything is broken down.
Yeah.
The manufacturers themselves, they don't care that much about standards and stuff like that. Where can I be to conform and to be able to sell my glass?
Yeah. So
And
let's have this conversation offline, Emmanuel, okay? Because
yeah, sure.
limited time here and still a lot to go, but I'll be happy to discuss that with you in another phone call, okay?
Yeah, we talked about it, and it's been a while, and I just wanted to see if there is any thing going forward.
Yeah. Okay. We can talk another time. Thank you.
Thank you.
So next topic 3 is window fall protection changes in part 3 and part 9. The minimum window opening height from the ground to prevent child falls. In part 9, the minimum height to the bottom edge of an openable window has been raised to 900 millimeters. So if it's as high as 900 millimeters, you don't need to have a guard or to worry about opening limitations. If it's lower than 900 millimeters, you do. In part 3, the requirements haven't changed at 1070. So the wording between the two parts of the code is not identical, but the intent appears to be the same except for the height of the opening a child could climb over. But the language in part 3 and part 9 has changed. And we discovered in an earlier session today that it sounds kind of like a window opening control device, but it actually is not. And I had actually misinterpreted the intent of the wording of the code language. So I was corrected in an earlier session, and I've updated this session accordingly. Basically, you can, if your windowsill is lower than needed to prevent someone from falling over in part 3 or part 9, you can protect it with a mechanism that can only be released with the use of tools or special knowledge to control the free swinging or sliding operation, to limit any clear unobstructed opening to not more than 100 millimeters vertically or horizontally. And this language of it can only be released with the use of tools or special knowledge basically rules out devices that are known as window opening control devices. And But the annex language refers to those devices too in confusing ways. So this is something that in an earlier meeting, the participants decided, we should do something about this to get some kind of a code interpretation or clarification, because it is confusing when you read the annex notes that correspond to this change. But the main thing that's important is just to understand that if the window opening is more than 1800 millimeters above an exterior walking surface or a lower floor, then you need to worry about fall protection. And if your opening height is less than the specified amount, and in part 3 it's 1070 millimeters, then you need to take other measures to prevent children or falling out. Either a guard, which would prevent them from climbing, getting to the opening, some kind of limiting device that restricts the opening to 100 millimeters. Those are your two options. And then virtually identical language in part 9. And so if you compare part 3 and part 9, that's where you're at. They both have the same limit to the outside. 1800 is the distance. If you fall less than 1800, you don't have to worry about it. If you're below the specified limit, if you're above the specified limit in part 9, now it's 900, it's been raised, then you would need a window opener, limiter, or a guard. If you are at 900 or higher, you don't need anything. So that's the new requirements for fall protection. I think just because of time, we won't go down the rabbit hole of the annex language. There was discussion of it earlier. But apart from that, are there any questions or concerns about this change? I guess that's where I wanted to get to.
Al, just to clarify for myself and others, when you refer to these as now being in place, that's just in the NBC, the National Building Code, and not in our provincial building codes.
Correct.
Until they are adopted.
Correct.
So we don't have to act on this today, only if they are adopted as written.
Exactly, yes. Good clarification, but that's the case, yes. Our national code is a model code that doesn't take effect anywhere. Apparently it takes effect in government buildings on publication, but otherwise they're the only buildings the federal government has jurisdiction over. Otherwise the provinces do, so.
But I think we could say that we would recommend that this be the best practice, because there can be severe liability associated with window falls. And knowing that the code recognized that this is an issue and attempted to improve, if now that you know this, you might get into trouble if somebody could prove that you knew this in an actual event that occurred.
Well, that's a good point. I guess if you're doing your work to plans and specifications created by an architect, the architect, of course, would face that liability more than you, wouldn't they?
No, that's correct. They're responsible for safety within within floor areas, but quite often the architect will say to the manufacturer and or the general contractor that we are putting that responsibility on you to be completely code compliant. And in the event of a lawsuit, I don't think they'd have a leg to stand on, but they're going to try and rope you in sometimes.
Okay. And I guess if you're selling windows to a private homeowner, do you have to worry about this?
Yeah. Honestly, if I was advising a private homeowner, with the code language currently at 450 and with an exemption for Part 9 homes, I would say if you wanted to put one of these devices in, like say in a renovation, and it's not currently required to meet egress, make it a releasable one. And it's just because we see the ones that are not releasable, they always get tampered with in mature buildings. People want to open their windows for full ventilation. And at least the releasable devices, you can release it, but then you close it and it re-engages for the next time around when there might be children in the vicinity, rather than the homeowner getting rid of it entirely, throwing it in the garbage, and then the new homeowner doesn't realize it was a requirement and doesn't twig to the meaning of these unfilled holes in the profiles.
Al?
Yes.
Dave, can I ask you to clarify your comment about 450 and an exception for part 9? I didn't understand that.
Okay, so let me be clear. In the national codes, it says that NBC 2015, it says it's not required if the window sill is located higher than 450, or if the window is not located on above another suite. And it's that second part that exempts all Part 9 buildings that are like single family, because you're never located above another suite. The language in BC doesn't have that second part. So in BC today, it's 450 and it's going to go up to 900.
Okay, thanks.
Thank you, Dave, for the clarifications. Fenestration energy performance. We touched on this in a previous session as well. We have a new subsection 936.7, tiered energy performance levels in NBC 2020. We don't have similar changes we haven't seen the BC code, but I don't think we're going to see these changes adopted by BC because BC already has a step code and is ahead of the national code. And Ontario changes have not been published, but we have seen the public review. Ontario did put out or propose changes for public review, so I'll touch on what those are. So the base code U factors and energy ratings have not changed since 2010. The only thing that's changed is that we're now using the metric U factors have been increased slightly from 1.80 to 1.84, 1.40 to 1.44. And that's just so that they convert nicely into inch-pound units, which I've shown in red down below. And that's just to make it fair for companies who certify through NFRC and have to start with an inch-pound number and then convert it to metric, as opposed to companies certifying through CSA 440.4, where they can work in the metric world, and a window that might actually hit 1.79, or let's put it this way: a window that can hits 0.32 gives you 1.84, but if you simulated that window in Canada with A440.4, you might actually have come up with a U factor of 1.80 or 1.79 or something like that. And it's not that the window didn't change, it's just the precision of your calculations. And because those who work with NFRC have to come up with inch-pound numbers, where the increments are 0.01, they are less precise than 2 decimal places in the metric system, and the conversion messes things up for people. So no change to the basic energy performance. They have added 4 tiers or levels of greater energy efficiency above base code level, and the base code level that we've had since 2010 is tier 1 now. The performance attributes of the new tiers are defined using performance metrics that require whole building energy modeling. So they've defined the performance levels for all the tiers. And they've also created a simple points-based prescriptive compliance path that doesn't require whole building energy modeling, but it gives the builder menus of defined conservation measures with points assigned to them. So the builder can choose simple options for menus that add up to the required number of points, and they don't have to do any energy modeling to ensure that the completed building will be more efficient, efficient to that level. And for now, they've only defined points for a single level of performance. BC pioneered the concept, and the way it works is that the code defines these higher level of performance, but it doesn't tell you which one's in effect. And that's the job of the authority having jurisdiction. So there are 5 performance tiers. Base code is the first. Tier 2 is where the Ontario SB12 is at today. And but in the National Building Code, it's tier 2. Tier 3 has not been defined in the national code, but Ontario is going to define it with a 20-point rating. And that's about the level of an Energy Star for new homes building. And then Tier 5 is at the level of the future aspirational goal building code, where we're building net zero ready buildings. BC steps are a little more stringent than the 2020 NBC tiers, but and in BC, several authorities having jurisdiction have already implemented steps 3, 4, and in some cases 5. But that's the kind of thing that will be coming to the rest of Canada. I think, have all of you been here in the earlier session? Is there anyone who hasn't been here in the early session? No? Okay. Then maybe we'll just, I'll try and make this quick. So essentially, for anyone online, the slide that we have now shows the percent heat loss reduction for the tiers. Tier 2 is supposed to be 5% better, less heat loss than base code. 3 is 10% better. Tier 4 is 20% better, and Tier 5 is 40% better than base code. And there are requirements in there how you calculate all those things and determine them. Ontario, the national code has defined Tier 2 as 10 points, and they've assigned points for windows, for walls, for plumbing fixture, for heating systems, and so on. And essentially, it allows the builder to achieve a higher level of performance without the energy modeling that would otherwise be required. I think I'll just zoom through this. And the question we asked at the end of this was, does this change the window value proposition? You know, for a long time, the builder just wanted the cheapest windows they could get because all windows were the same, right? Now, the builder might have to upgrade the insulation in a wall or the roof or in several parts. The builder might have to spend a lot of money doing all kinds of things to reach a higher level of performance. And they might find that depending what zone they're in, upgrading to an Energy Star window, which costs more money, might actually be less expensive than other things they would have to spend their money on to reach the same level of performance. So I think windows will now, more expensive, higher performance windows are likely going to become more desirable to builders.
Al?
Yes.
So the NBC 2020 has Tier 2 confirmed.
Yes.
When do we expect to see the other 3 tiers? What those values are?
Probably not till the next code.
Wow.
Basically, they're taking a baby step in the direction of the step code. And, you know, Canada's a lot bigger than BC. You've got provinces, territories, and a wide range of variables. BC went in under the step code. Every building needs an energy model if you're going up step 3 and higher, right? Am I right there? Or
Yes. Yeah.
yes.
That's
Okay.
correct.
Yeah.
So that being the case, then we would see the next NBC 2025 with a 2-year timeline to adopt to the provinces, 2027 before we would see those additional values. Does that sound right?
You know, it could be as late as that. I don't know if they will decide to do some work in between code cycles and issue some kind of interim update with intermediate tiers. It's just that the whole idea of tiers and levels is new, and they probably are concerned whether they have the modeling capacity in terms of energy advisors and others to do all the simulations that you would need to reach those higher tiers. So they put in place a points-based program to simplify that and ease the transition,
Right.
For the industry.
Yeah. I just reran the dates in my head, and it's actually 2029 that we would see it in the provinces.
Right. Yeah.
If they follow this.
Yeah.
Okay. All right.
So I think, the expectation that our 2030 codes would be net zero codes is we're already 5 years behind, I think. But it might be something that happens in 2035, Combustible window frames.
Al, before we go into combustible windows, because that's another pet peeve of mine, I want to go back and remind you that our standards being renewed every, I don't know, 3 years or so, they do not match what the marketplace is working with. So how can we address this situation when a local municipality standard been adopted 10 years ago requires certain things, and we come up with the positive situation when we come up with better things, and we still cannot meet their requests because it doesn't match what they have in front of them as a paperwork versus what we are offering now. So a big improvement. Case in point, the glass, or, but the municipality do not recognize that added advantage because they are in the 2005, let's say, building code mentality versus 2020, which was adopted just yesterday. How can we deal with these things? Is it okay to show that we are compliant with 2020 supersedes and is better than what you, building inspector, are looking at as of 2005? How can we deal with these situations?
Well, I don't see any way of dealing with it. I mean, the building code is adopted as a bylaw in a municipality, right? So until you adopt it,
Correct, but sometimes could be in, how should I say this? Could be against what they knew. Who's telling them, no, this new one is better, or it's the new norm or something?
but you can't do that because there might be a reason why they chose the old standard in the other version of the code.
They didn't choose it.
It's
They
just,
are simple workers
yeah,
that they were given. This is what you work with.
yeah. This is not a problem we can solve as an industry, Emmanuel. It's just the speed at which the world works, and not all the parts move at the same time. It's life.
But you do understand how frustrated I am about these things, working with actual manufacturers.
Yeah, it can be a problem. It can be a problem. Yes.
You know what the problem is, though?
Emmanuel, I'm going to have to call a point of order here. It's a little bit off topic to the code update. And we do have a lot of material to cover here. So perhaps you could discuss your concerns offline.
Thank you very much. I agree with you. My problem is that the other people outside of our limited world don't see the problems or don't see what we do for them.
Right. And I guess sounds like a customer management issue. So, we'll move on then to combustible window frames. In non-combustible construction, you probably already know this news, this wonderful news. Essentially, all the restrictions that were in the code in red were removed, and the only thing that was added is the words in blue. So now, combustible window sashes and frames are permitted in a building of non-combustible construction, provided they are vertically non-contiguous between stories. In other words, they can't touch from floor to floor. You can't have a 30-foot high combustible window framed window if it's passing the slabs of several floors for several stories. And the concern of some people when they saw this code change is they thought that now the door is wide open for combustible curtain walls and combustible window walls. And they felt that, you know, that's going too far. And so essentially there's no restriction on the size of windows. So you can have floor to ceiling windows from floor to floor. It's just that you can't have a continuous framing system that goes past the floors, past the slabs of the building from combustible material. That's your only restriction.
Al,
Yes.
is there a value of non-contiguous? Is it 1 inch, 6 inches, a meter?
It's language contiguous. You look it up in a dictionary
don't
and then
touch-
you can parse, right? I mean, contiguous means two things that touch together or are very close to each other. In
Okay.
other words, there's nothing in between them. I guess that's the way to think about it,
Okay.
right? So potentially you could say, hey, yes, there's a ½ inch in between the frame below and the frame above, but you know, essentially that's continuous. I don't think anyone would buy that as being, you know, non-contiguous, shall we say.
But
But
if you ran windows floor to ceiling and there was a, whatever the floor span in between was 14 inches, let's say, and another window floor to ceiling, that would not be,
That's right.
okay, great.
Yeah, yeah. So essentially, if you're going slab to slab or floor to floor with floor to ceiling windows, as long as the material that connects those two is non-combustible, then that would be permitted under this, unless some building official interpret it their own way. You know what I mean? You always have that problem, right? But
So-
I think the language is quite clear.
If I'm not mistaken, it used to be a meter. Is that
Well,
Is that what it was?
it was a meter before, yes.
right? So that's gone.
That's gone.
Okay, thanks.
And the area limits are gone. You know, 40% of a fire compartment. There's no limit that way. So if you could now have a ribbon window around a whole building of combustible windows, right? And it could be a ribbon all the way, you know, floor to ceiling glass all around the building in principle as well, as long as they're not vertically contiguous, right? Yeah. So that's the good news. There, yes. So the concern was window wall and curtain wall. It's interesting to me, and I've written an article for Pat in Fenestration Review. Actually, that should go into Glass Canada, not Fenestration Review, because it's the readers of Glass Canada. Is it Glass Canada? Okay, yeah. So at the time this code change was being debated, a company had already introduced to the market in Canada an all fiberglass stick-built curtain wall. And within the same year that this was being debated, another company in BC launched their fiberglass window wall system. And it is and there's wood. There you go. Yeah. So we're going to be seeing timber and other materials now in these floor-to-ceiling assemblies, which is the way it should be. Great. This is a project I worked on back in 2012, and these were PVC windows, floor-to-ceiling PVC windows. You know, today you could do that job without needing an alternative solution. So I'll just touch on encapsulated mass timber construction briefly because, you know, we've made a lot of progress in the code. There's a whole new subsection devoted to this kind of construction. And essentially you can build solid wood buildings, wood frame structural beams, columns, floor slabs, and panels. And it's called encapsulated. The whole idea is that you can wrap the wood in material that will protect it long enough for the fire to be put out. And you can actually have bare wood exposed if within some defined period of time, the amount that gets burned or charred does not reduce its structural capacity beyond what it was designed for. So in other words, they're just using intelligent design, you know, and testing to establish safe parameters for all wood buildings, which is pretty neat. This is a really large project in Montreal, but just shows you what people are now doing with encapsulated mass timber. And the main reason I'm mentioning it is because, unfortunately, the removal of restrictions on combustible window frames does not apply to windows that are in encapsulated mass timber buildings. Go figure, eh? And the problem is that the code change that removed the restrictions was launched separately from the encapsulated mass timber changes. So the encapsulated mass timber code change request didn't address windows, it just addressed the structure of the buildings. So those are two separate code changes that were approved separately by the same committee, but the wood buildings don't get wood windows, and all other buildings get wood, PVC, and fiberglass windows. So I'm sure that somebody's going to make that change for the next code cycle. Any comments or questions on that? Oh, well, we still have a few minutes. Interested in accessibility changes? This might affect some people. There are now minimum clear openings of access to exit doors has been increased. So that could affect door slab sizes. So, so the minimum clear opening of access to exit doors has increased from 800 millimeters to 850 millimeters per door leaf. And that's the actual code language there. The crossed out numbers, they were 800, now they're 850. And another area is interesting is that all pedestrian entrances to a barrier-free story of a building referred to in sentence 3821 shall be barrier-free and shall connect to a barrier-free exterior path of travel. So there are now defining barrier-free paths of travel within buildings and barrier-free, they're greatly expanding the zones that are required to be barrier-free. And so that's affecting things like door widths and will possibly also affect thresholds where there might be areas that require barrier-free access where we now rely on some kind of a step threshold for water tightness or something. And, you know, we might have to deal with that. So these are changes that still have the potential to affect our industry. I don't work enough with doors to understand what the implications might be to the non-commercial door market. You know, this might just end up applying to products that we would call commercial. So that's basically it. Thank you. This is your 2020 NBC code update. It's not as bad as we feared. I think there's a lot of good stuff in it. And honestly, the steps they're taking in the energy efficiency area are not as strong as they took in BC. So I think the rest of Canada is going to have a fairly easy time dealing with this. I think by the time a more stringent code rolls in, you know, all of us will have more products ready to meet that code on the market and a lot more awareness in the construction industry and among builders about their value. So thank you very much for your attention. You are now freed from detention.